I'm Sneha from Web3 Compass, and this is day 14 of 30 days of building with Solidity. I think I'm still in my Sunday vibe because yeah, I mean, come on. We had to work on weekends, not complaining about it at all, but Monday is not very mundane, and today's contract is going to be a little complicated than most of it, and we're going to write too many, although they are all small, cute little contracts, but then you have to have a lot of patience, and this video will probably be in two parts. So make sure that you watch both of them. Again, my same iconic statements that people who are with us skip, go till to the point where I'm talking about remix. To the ones who have just stumbled upon this video randomly, you need to watch our previous day videos to understand what we are doing, to understand more about the campaign, especially go and watch day 1 video. And yeah, make sure you hop on our Telegram. That is where we do all the talking with the community and plan some cool stuff later. So let's get started. Today is day 14 and we're talking about a smart contract called SafeDeposit.Sol. The concepts that we'll talk about is interfaces, a new thing that we have not covered yet, abstraction, ownership transfer, contract to contract interaction. We've already looked at ownership transfer, contract to contract interaction, so we'll just be implementing it. As an example application, we're looking at building a smart contract that offers different types of deposit boxes, basic, premium, time logged, etc. Each box follows a common interface and supports ownership transfer. A central vault manager contract interacts with all deposit boxes in a unified way, letting users store secrets and transfer ownership like handing over the key to a digital locker. This teaches interface design, modularity, and how contracts communicate with each other safely. Oof, that was tough. Let's get started. Okay, so a little before starting the project discussions, as of now, we've written a lot of things from a calculator to a simple IOU app to an ERC20 token, talking about a pre-sale token contract and all of that. Explored a lot of concepts from data types to functions to inheritance, all of it. And now it's time to level up a bit. We're writing or building a modular vault system. Again, I know we've written a vault manager.sol contract before, but this is, the name is going to be similar in this one, but that is not what we are implementing. So make sure that everyone who has attempted that challenge, you change the name of the previous one as vault master previous, something like that. And yeah, and then get started so that when you're importing, or even for this one, maybe you can use something else. It's totally on you. But yeah, I just don't want you to get confused with the naming convention. Now, as a picture of the project or what we're going to talk about today is that we've got users and each of them wants to store a secret in a personal vault, but not all the vaults are the same. They're like tires, okay? Tier system, not tires. tier system, tiers. So some are basic, meant for everyday use. Some are premium, offering bonus features like metadata. Some are time logged, where the user can't open a vault until a certain time has passed. Instead of writing 3 completely separate contracts, we're going to build them very smartly using shared rules, common logic, and Solidity's powerful object-oriented features here. That brings us to one key concept we need to understand before diving in, which is interface. Okay, so if inheritance is about reusing a common logic again and again so that you don't have to write same lines of code, interfaces are about enforcing structure. So an interface in Solidity is basically a contract with only function definitions, no logic, no storage, no state variables. Think of it as a blueprint or a promise. So any contract that implements this interface must include these functions and they must behave as expected. Okay. So it's like setting a standard, which has some major benefits. It makes contract interactions predictable, even across different types. It lets us write tools like managers or dashboards that talk to any contract that allows the interface without knowing the full implementation. It keeps our system very modular and flexible. So we're going to use an interface to define what every vault box must support. For example, who owns the box? Can they store and retrieve a secret? What type of box is it? When was it created? And all of that. So each vault type will then implement this interface in its own ways. Okay. Now, there's something called as abstract contracts that we're going to talk about as well. So alongside interfaces, Solidity gives us another powerful tool, which is called abstract contract. So an abstract contract is a contract that can have both implemented functions and unimplemented like virtual functions. Basically a mix of interface and real logic. It is useful when you want to provide shared logic like common variables or internal helper functions. Leave certain pieces to be filled by child contracts. So as a key idea, I would say we use abstract contracts as foundations. They're not meant to be deployed directly. Okay. So in our vault system, we will build an abstract base contract that handles shared logic like tracking the owner of a vault, storing and retrieving secrets, enforcing access control and stuff. And then our basic, premium and time logged vaults will extend this base contract and add their own flavor, all while conforming the interface that we have, set up. Okay. So we'll get started with interface. There would be multiple contracts that would be written throughout this session. So make sure that you're prepared for it. I'm not scaring you off. Come on. They are very cute little tiny 5-6. Some contract is like 10 lines and all of that. Only one contract, which is the major implementation, would be extended one, but don't worry about it. We'll go about it slowly. And also remember that you can read more about interface and abstract contracts online. That is one of a very popular interview questions if you're facing interviews in Solidity. So good thing to know. Okay. Now let's get started. There's no point in zooming in. Okay. So I'm saying I deposit box.sol. Okay, so this is the interface. This is the interface that we'll talk about. And we're saying, okay, we're defining a simple rule book of required functions. Every vault will be required to follow this. And what I'll do is I'll create all the files first. Okay, so there would be a base deposit box.sol. Now it's totally on you how you want to structure this entire thing. We thought of this vault system tier based and all of it. So that is why we're going about with this. And we'll show you how, all of these, again, interfaces, abstract contract and all of that is brought into picture. Okay, so we've created 3 of them and we've also talked about time logged deposit. Sol. I really miss my mechanical keyboard. Manager. So, okay. So 1, 2, 3, 4, 5. We had time. No, we had one more. We would also, I forgot. There would be a basic deposit box as well, because that is the tier we are talking about. And then one is the base deposit, which is again the abstract contract. Okay, so 6 of them. Don't worry. Please don't run away. Don't pause the video. Just be patient and we'll see all of it. Okay, so let's look into the interface. Okay, we're saying interface. Okay. Interface, I deposit box. Okay. And we're saying function get owner, because again, we've already told you that who is going to be the owner of the vault. So, and we want this to be an external contract. Again, I'll talk about all of these. And then we're saying, hey, returns address. Okay. So this is going to be the interface contract. It's the contract blueprint. We're basically saying, hey, any vault or deposit box that wants to be a part of our system must implement these functions. And we'll go over these functions one by one, right? So the get owner function is going to talk about who is the owner, or it will return the current owner of the box. Okay. And then we're going to write function transfer ownership, and we're saying address of the new owner and make it external. Again, we want it to be accessible by outside. So yeah, that is why. Then we're saying store secret, a function to save a string or our secret inside the vault. So we're saying, hey, function store secret. Now you'll see a new term here. Generally with string, we use memory, but then here we'll use call data. Again, this is a gas optimization technique. We're going to cover gas optimization in detail in the coming sessions, but you should know something that all of these things are going to cost gas, and we have to look into optimizing all of it so that lesser gas is, consumed. And then we're saying, okay, store secret. So there should be a get secret, which retrieves the get secret, or retrieves the secret that we're talking about. So we say get secret. Okay. And yeah, that has to be a string, memory, or call data, whatever. And then we're saying, okay, there should be a get box type. So let us know what kind of box it is, or which tier is it, basic, premium, whatsoever. So we're saying function get box type. Again, this has to be external, pure, because we're not modifying anything. We're not reading anything from the blockchain. So that is why it could be just pure. And we're saying memory. And then would be get deposit time. So returns when the box was created. And these are like the rules of the game. Every deposit box type will follow them, even if they implement this differently. So these are like mandatory stuff to do. It's like you've set the game rules, okay? Like these are mandatory rules, and then yeah, if you want to play it differently, it's fine, but you have to, right? So this is the interface that we're talking about, okay? What is the Okay, we're not literally looking at basic deposit box right now, but we will write it when we do it. So you already know that the license line and all of it should be there. 1 second. Yeah. Okay. Let's see what happens if we don't like really, write this. And then we say, okay, now we will go to the base deposit box.sol, which is our abstract foundation, and that contract will be the core of our deposit box system. All specific types of boxes like basic, premium, time locked are built on top of this contract. And let's start by understanding the top level structure. So where is our base deposit box? Yeah. Okay, so we will just copy these 2 lines here. We'll copy it here and we're saying that we have to import, okay, what? Dot slash I deposit. Sorry guys, I'm a little lost and a little sick today, so ignore if I make these mistakes. Okay, so this is okay, fine. We're saying not provided in the source file. Yeah. See, these are the things you will get. What? Why is our iDeposit box empty? Oh my god, that is why. Because I wrote it in the wrong file. Come on, guys. You should have told me. God. Watching me live. Okay. Yeah. Why am I just missing out on these things? Yeah, base deposit. Okay, great. Fine. So now we will make this contract as abstract. We won't really need to like deploy it separately. We're saying abstract contract base deposit box is iDeposit box, right? That is how you do it. That is how you're going to inherit the entire thing, right? And we're saying, okay, think of an interface as a contract that only has, we've already talked about it, right? That interface only has function declaration, no actual implementations. By importing and inheriting from it, this contract is saying, I promise to implement all the functions declared in iDeposit box, even if none of them, all of them are written here yet. So this will help us enforce structure across all deposit boxes, right? And here the keyword abstract means that the contract cannot be deployed directly. It's designed to act like a template or a foundation for other contracts to build on. And why did we choose to make it abstract is because it does not fully implement every function required by the interface. For example, it won't define the get box type later. Okay, each child contract will define that differently. Like the basic type will define it differently, the premium type would define it differently, and all of this. So this base contract handles the common logic, and each specific box fills in the rest. Okay, so now let's look into what are the state variables that we're going to talk here. Okay, so we need a address. We make address of the owner, right? So we make it private and we say, okay, there should be a string private secret because that is the entire motive here, to store a secret in the world. And then there should be a UN 256 deposit time, right? That is when we are like, when the box was deployed. Okay. Yeah. Okay. So these are the things. Again, very simple variables, nothing fancy. Owner, address of the person who owns the deposit box, secret, private string that the user can store securely, and deposit time is records the exact time when the box is deployed. Okay. Now, all of these are marked as private, meaning they can only be accessed internally. If someone wants to read them, they must go through a public getter function, which we'll provide. And then now it's time to think of some events. So we've talked about ownership transferring in the interface. So that would be one event. The secret storing can be another one. These are the only two I could think of. So we are saying, okay, fine. If you have any other ones, please go forward, write them, address, index, previous owner. These should be really, really easy for you because come on, right? This is predictable that this is the exact line that I'm going to write, right? And event secret stored. Okay, and we're saying address indexed owner. Okay. Now, great. So, we've already talked about why events are important for on-chain activity and they're useful for front ends and all of that. So, an indexed helps you filter out. Great. Now, before we write the constructor, yeah, like we can just go about writing the constructor. No before, no after. And we're saying, okay, the owner should be message.sender. Okay. And the deposit time should be the block dot time stamp. Great. Yeah. Now there should be a modifier. Only owner, right? And so that when we're talking about restricting certain functions to owner only, that is what we're going to use. Okay. So we're saying, what do we say when we talk about only owner modifiers is owner equals to message.sender. And if we can say, hey, not the owner, or only the owner can perform this function and stuff like that. And now it is by default written the get owner function, which is, oh my god, no. Okay, so now that we've done this, you should know message or sender again, you know the contract to deploy the owner. Block.timestamp would be the current time in seconds in Unix epoch is recorded as a deposit time. So the box will set up both ownership and time tracking automatically at the creation. Now we will quickly write a function. We'll get. I like to write cute little functions. Keep it like simple. Helper functions, view, override returns address, and return what? Owner. Okay, so this will return the current owner of the box. It is a simple getter function and required by the iDeposit box interface. Again, we did not write this. I'm so sorry. AI stuff, doing things. Okay. I think this is too zoomed in. I think this is better. Yeah. And now we'll think of writing what? Transfer ownership, because again, our interface asked for it, right? So transfer ownership, and we're saying address, new owner. Okay. And then we're saying, okay, external, but also virtual. Okay. And overrides only owner, right? Because only the owner can do it. And we're saying, hey, it will allow the current owner to hand over ownership to someone else. It will check the new owner's address is in the 0 address, which we always do, and then emits an event to signal the ownership change. Okay. Now, all of these, we've already talked about what is virtual, what is override here, and why do we actually need it. So you need to go back to the previous videos to actually look into that. I will not explain this one. It's already going to be a lengthy one. Can we just... Okay, so this is the ownership thing. Why does this look so zoomed in? It's fine. Okay. Now, yeah. So this is done. Now we'll have a function to store secret. Again, we need it because of the interface. Store secret. Oops. And we're saying string call data secret. Again, memory. We're not using memory. We could use memory. It's fine, but call data is more gas optimized. And we're saying virtual override. And we're saying secret equals to underscore secret. And then we'll emit. emit secret stored, and then the owner would be message.sender. Very simple. Okay. So we're saying it only accepts a call from the current owner, stores the secret in the private variable secret, and emits an event after storing. And yeah, that's it, right? And then we would quickly write function get secret because that is the one that's left. So we're saying, okay, function get secret. Okay, we can make it public. There's no need as such. It will be a view function because it does not, cost gas if called externally, like from a front end or whatsoever. And it will be, okay, virtual override only owner returns string memory return secret, right? So it will be marked with only owner to ensure privacy and no one else can see the secret. And then there's one more function that we're going to talk about, which is the deposit time. Okay. So we say get deposit time. Very cute little function again. Say external view virtual override only returns u into 56 and return deposit time. That's it. That's entire. So it will return the time the box is deployed, used for time-based features. For example, if the secret should only be revealed after a certain number of days. Quickly go by. And then you see, okay, deploy. Oh, see? The contract may be abstract. It may not implement an abstract parents method completely, or it may not invoke or inherited contracts constructor correctly. So that is why we cannot deploy it. Okay. Now we're saying it's time we write something else. It's time we write basic deposit box, right? So we'll go back quickly to this and we'll say, okay, where is our basic? It's here. We're saying, hey, this is good, but this time we'll import the base deposit box. Okay, and we say contract basic box is base deposit box. Okay, great. So we're saying that if at this first glance, even when I was writing it, I was like, oh my God, this contract is like 5 lines. Like, am I writing the right thing? Right? But behind the scenes, it is very powerful because of everything it inherits from the base deposit box. We start by importing the base contract. This gives us basic deposit box access to everything defined in the base: ownership management, secret storing, retrieving, deposit time tracking, access control modifiers, events, etc. And then we define a new contract like contract basic deposit box is base deposit box. This means make a new contract that inherits all the logic from base deposit box. So we don't need to rewrite all that logic and we simply reuse it. Okay. And this is the power of inheritance. We've already talked about it. You only write core features once in the parent contract and extend them as needed in child contracts, right? And here we'll only write one. We'll say function get box type, like we talked about it, that we're just going to leave it as separate contracts and then they can implement it on their own. Pure override returns string memory. Okay. And then we say, hey, return basic, because that's it. That's it. That is the tier that we're talking about. So external is only meant to be called from outside the contract, example from another contract or a front end. Pure It's not writing anything on the storage or reading it. It simply returns a hard-coded string. It's overriding the abstract get box type function, which is declared in the interface iDeposit box and left unimplemented in the base deposit box, and returns string memory. Again, it gives us the basic box type, which in this case is basic, right? Why is this useful is that, let's say you have many boxes deployed, basic, premium, time locked, and you want to know what each type of the box is. You can just simply call the get box type and get a human readable label. This is especially helpful when you're building things like a front-end dashboard, sorting logic in the Vault Manager contract, on-chain analytics, and all of this. But what is this contract actually doing, right? So even if it's just a few lines long, basic deposit box gives us a fully functional, secure, owner-controlled deposit box. It can store a secret string, only the owner can set or retrieve it, transfer ownership to someone else, emit events when secrets are stored or owners are changed, and report its own box type as basic, right? That's all that we wanted. And all of that power comes from the base contract, which is the base deposit box. Again, an abstract contract that we were talking about. And we just added one specific label to identify this type of box. We can just go compile this. And if we go deploy it, you will see, wow, there's everything. There's store secret, transfer ownership, get box type, get deposit time, get owner, get secret. It's empty, right? So great work on that, right? Now we're building on top of our base deposit box again, and we'll build something called premium deposit box, which will come with extra metadata power. But now we're giving the deposit box like something extra, a piece of data, okay? Not just the label that as we did in the basic one. And you have to think of it like a personalized label tag or an info field, right? That the owner can set. Like, it's more information comes in. It could describe what the secret is about, when it should be accessed, or any other note. Anything that provides more information about the data is called the metadata, right? So let's just get started, right? Let's go to premium deposit box, but let me just copy this. Okay, copy this entire thing. And I will say, okay, import base deposit box, but here we'll make this premium. Premium deposit box is base deposit box. That's it. Let's get started. Okay. So we're saying we need something called as metadata. We've already talked about it. And that is the difference between the basic and the premium one here. So we're saying string private metadata. Okay. And for this, we might want an event that, hey, something new is happening. Metadata got updated. Okay. So we're saying metadata updated. Okay. And we're saying, okay, what is it going to be? So it should be the address indexed owner, like who updated it. So, right. We need that information. Come on. Right. So, I don't think I need to explain the import section here and what is it doing. You already know base deposit box is giving us ownership access, secret storage, event logging, blah, blah, blah. And with metadata, it's a simple state variable. We've marked it as private, which means only functions within this contract can read or modify. And we'll create an external access functions for the owner. And this could be anything. This could be used for anything, a label like backup keys or note like access after retirement, etc. Right? And then for the event, we are when someone stores a secret or transfer ownership, we do the same here when someone updates metadata. Why? Because it helps off-chain systems, front ends, explore or track changes. It improves transparency. It makes debugging easier. And we also mark owner as index so that it can easily filter or search in the logs. Okay. So that's it, right? Now there would be one thing called as function. Get box type. Wow, so unpredictable. No, it wasn't, right? It's the same thing. I'll just quickly, it's just coming like this, right? Okay, we'll implement this, but not right now, right? So we say premium, we don't need these. Everything else is fine. This is same as how we did for basic. Now, when it returns premium, it helps other contracts or front ends identify and label it properly. And this is required by the interface deposit box and helps us distinguish between the different types of tier of boxes that we have. Now, the other thing would be a function set metadata. Yeah, let me just get the AI to work because it really, really wants to help me. And let me explain everything. So we're saying there's a function set metadata. It's taking string call data underscore metadata. Again, you can use memory, but call data is more gas efficient. We're using external because only callable from outside the contract, not internally. Only owner sets the modifier that, hey, the modifier from base deposit box will help us restrict access, and only the box owner can update the metadata. The new metadata value is passed in as an argument in the form of underscore metadata. And then we have updated the store value, and then we have emitted the event metadata updated with message.sender. Again, logging the change for transparency, and this will give the owners a way to attach nodes, categories, whatsoever, right? Now that we have set a metadata, we would want to get the metadata, right? So we're saying function get metadata. No. Okay. And again, cute little function, just quickly returns string. Okay, and we're saying return metadata. See, I love these cute little functions. No implementations at all, no brain required. So then this function will let the owner retrieve the metadata that they previously stored. It's a view because it just reads from the storage without changing anything. And again, it's protected by only owner. And yeah, no one else can see what you've written, right? So that's it. That's the entire premium deposit box. And very similarly would be if you deploy this. Dun-da-da, there's everything, right? And then very similarly would be time lock deposit box.sol as well. Again, a little more modification that we have done where you can store a secret, but you can't retrieve it until a specific time has passed. More like a digital safe that stays locked for a set period. No matter how badly you want to open it, you've got to wait. We inherit from our Trustly like base deposit box again. But this time we add timing logic to control when the secret becomes accessible. So a lot of this would be same, and we'll just implement the new segments. Okay. So let me just copy. Okay, wait. I think I should do this in part 2 when I talk about the time lock contract and the main vault manager contract as well, because that would be like a really, really long one. So yeah, I'll see you in part 2. Bye guys.